Hello everybody, welcome to the stream or the video if you're watching this back at a later date. Today's task is going to be trying to make a repair on specifically some Camco Vortex amplifiers. Now these are some amplifiers that I've been looking at now for about 4 or 5 days. I've never ever repaired one of these amplifiers before, never even seen one before in my life before I got 7 of them sent to me for repair, and as luck would have it, there's absolutely zero schematics or data sheets, service manuals or anything available online for these amplifiers. The only thing you get is a user manual, which, given the user manual goes into a bit more detail about its functionality than most user manuals do, but it doesn't really help us with a repair. So I've spent the last 4 or 5 days kind of reverse engineering these circuits, trying to work out how they tick, how they work, and what the faults are with them. I've got a range of different faults. Fortunately, one of them was a no fault, so I do have a working example here with me, which is a fantastic thing to have if you're ever trying to repair something and you don't have any information or schematics or data sheets or anything like that. Then having a working example that you can just take multimeter readings from and voltages from and compare to the ones that don't work is like literally your key to getting it fixed. So that's been pretty cool. I've ordered some parts for them because I've figured out what I think might be a couple of issues, and the issues are like a freaking headache. Like they're not the sort of things you generally think that would be bad with circuits, but it seems to be bad, so we're going to go from there. But just while we get the stream cooking, let's have a little look at some live chat, and also just while the stream picks up, because it usually takes a couple of hours for the stream to pick up. The first thing we're going to be looking at this evening is just this little B2 audio car amplifiers, Rage 1200.4. Again, no schematics for this, but we're very well versed with car audio amplifier repair here, so we're not going to need a schematic for that. But how's it going, guys? Hope you are good. Do you see my comment, bro? Says Pradeep. Yeah, man, I see your comments loud and clear. How's it going, Adrian? Leo's, Jordan, Larry's #1 as always. My man's hot on this live stream thing. He's always first on the chat. What's up, 13BTRX? Good to see you there, buddy. Love to see you always. Oh, my X-Fire 7.5K is still going strong after all them visits to you. Oh, dude, that's Stephen Ford. Sorry if we didn't want your name, but I just remembered who that was there. Glad that this is working okay for you now. What's that been in for? That has had gain potentiometer really bad. The master slave switch bad. Did it have bad? Oh, it had popped caps, rail caps popped. This is a Xenon built amplifier, so they always pop the bloody rail caps, nightmare things. My LW audio amplifiers that I distributed like years ago, they're all starting to have that issue now, and obviously didn't know it at the time, but the rail capacitors that Xenon factory uses were not very good, and they all fail after sort of like 4 or 5 years quite dramatically. But glad that it is. Oh man, Adam Thomas, ever been shocked? It's funny you say that, because 2 or 3 days ago, while I was diagnosing these Camco PA amplifiers, I got a nice 240 volt AC tickle off the mains. Scarily, I got it across the chest, which is not what you want. But luckily, the resistance of my body at that given time was high, or whatever I was touching was high, and yeah, it was a bit of a whoa fuck, and then easy to let go, and no harm done, fortunately. But that was a bit of a wake-up call. So I'm not super well set up here for doing PA amplifiers. I'm typically a 12 volt technician, so all of my bench setup and everything is all set up for low voltage power supply stuff, and taking on more PA amplifiers now, I definitely need to get a kind of Mend It Mark style mains supply setup going for working on main stuff, and a lot more power. You can never have enough tracking power supplies for injecting various supply voltages into these boards without actually having to connect the mains, so that's something that we want. But yeah, the shock that I got, I actually holding on to this, here we go. So basically, for the PA amps, I have this, which is just a little extension, kind of single extension plug, right? So I can have it in my hand and like quickly off the mains, because you know, if anything goes wrong, I can quickly off the mains with it in my hand here. I should probably get a foot pedal because I have 12-volt remote on the foot pedal for the car stuff. So it'd be cool to have 240-volt mains on the foot pedal. I instantly remove if need be, but this is what I've been using just for the time being. And so I was holding this with one hand, and the other hand I had the amplifier disassembled. And stupidly, I assumed that the power switch on these amps, because of how the boards are laid out, it looks like the power switch is just a logic level switch with like a 3.3 or 5 volt or 12 volt on the switch that then sends that to some circuit that then activates the 3525 oscillator to get the amp power supply up and running. Didn't think it was actually connected to mains because of how the circuit's laid out. So there's me with the freaking switch, like, hanging off the board. One hand on this will be grounded. So there's that as ground, and then there's me, reach over, grab the switch. So, but interestingly, the mains does have RCD, so it should trip the breaker if it detects current flowing to ground above a certain threshold, which it didn't. So I guess this is kind of painted or something. It doesn't look painted, but whatever happened, the resistance of either me or a combination of me and the coating on this or whatever wasn't wasn't low enough to cause enough current to pass, but it did certainly feel strange. Got a Crescendo Symphony S600.1 that I'm trying to repair. Can't find schematics nowhere, says Leo's videos. Dude, fortunately, those things are pretty simple. If you are struggling with parts or what circuit is the problem, then send me a message on BearVid's Facebook page, facebook.com/BearVids, just with the issue, and I'll help you out. You don't like if you know car amps a little bit, you don't really need schematics for those sorts of things. What's up, David? How's it going, buddy? What's up, Amir? What's up, Dusty? Thank you for your appreciation. No worries, man. Anytime. Yeah, I'm all good this evening, Connie. Just got my lemon grab cup of tea here. I'm a bit of an Adventure Time fan, you see. Been working on my books. Gonna have to take all the seats out to get it in and out. Oh, that's a mission. Is it a saloon where you were getting it? Oh yeah, wait, weren't we talking about, there was someone recently on a stream that built their box too big, and I was like, is it a saloon? Because you measured the inside space, but you didn't actually measure how to get it in the boot, in the trunk. Hey, from New Zealand. Yo, how's it going over in New Zealand? New Zealand's actually a country I'd love to visit. Seems pretty nice over there. Right, so just while the stream picks up a little bit, I'm just going to take a quick peek at this, which is a B2 1200.4 4-channel Class D car amplifier. These things are not that well optimized from what I've seen previously. They run the dead time far too low on the output section, on the output FETs, and it runs, some of the ones I've seen of these, they run really freaking hot at idle, and they run so hot in fact that even under normal use with the speakers wired to or above the minimum recommended impedance, the things freaking overheat. Not even in the summer or the sun either. They just, there's too much cross conduction on the output FETs, and we do fix that by changing the dead time mode on the 2092s and the 2093, etc. But let's see if this one needs it. The screws are actually not the correct ones, so this may have been in for a repair previously. Yeah, I think I recognise this one. Okay, so this one's been worked on before. I don't know if I've worked on this one or not, but we have, because these are white PCBs, so if the power supply FETs fail at any time, then it's kind of difficult to clean that off. You get the soot, and there is actually just some sort of like, looks like some soot or some flux combined with soot or something that's been left over there, but that's not a problem. I mean, it's just a white PCB, so it looks a bit of a shame. But just remembering these boards, one of the reasons actually, this one's come in, and the issue, if I can just get this without giving any personal details of this away, this says, Here we go, that'll be fine. Powers up, doesn't go into protection or anything, but doesn't produce any sound. It will eventually, but it takes a while. It'll play for a bit and then it goes off. And you're back to square one again. So we've got a case where they've got the amplifier powering up, no protection mode, got a blue light, everything seems to be fine, but no sound. But then it kind of comes and goes. So that is giving off the telltale signs of a poor connection, snapped solder joint somewhere perhaps. But because I know these boards, my attention is drawn to these. So on the board here, we've got some little surface mount resistors, some 47 ohm resistors right here. And these are in the auxiliary supply voltage circuit, I believe, from memory. And as you can see, these run hot. These run far too hot. The resistor ratings have not been spec'd correctly for this application. They run far too hot. And what happens when they run hot is the solder connection to the board just becomes unreliable. The actual resistors themselves look okay, but the solder connection becomes a bit unreliable, and you can end up getting a break, you know, where all of a sudden the preamp circuit isn't actually being fed with plus minus 15 volts for the op amps, therefore you get no sound. So what I'm going to do is, before we actually touch it or do anything, I'm going to power it up and just confirm that we don't have any audio. If we do get audio, it's a bit annoying because we're going to have to wait for it to disappear, or you know, I want to see the fault first. I want to see the fault so that I can then trace it and figure out what's going on before I then fix it. But if we don't get the fault at first, it's a little bit annoying, but not the end of the world. So let's get some power wires and plug her in. Turn the old scope on. I would love a new scope, not gonna lie guys. I love my scope, don't get me wrong. But I want one that is that has a faster processor that can display more on screen without kind of like lagging. This is an ancient beast. This HP is old. The processor is very slow in it for, you know, compared to modern day times. Let's get this camera focused a little bit. And yeah, it struggles a bit when it's doing voltage, voltage, duty cycle, and frequency measurements at the same time as doing like rolling screen waveform. It kind of stutters and stuff. So I also want a multicolor screen so I can actually bloody see the difference between channel 1 and channel 2, because at the moment we've got channel 1 and 2, and the only way to differentiate them is to like separate them apart a little bit. And yeah, I want a nice big ass screen. I want data logging. Oh, data logging would be sick, especially for intermittent faults. I can go down, make a cup of tea, leave something running, and then actually just look back at the whole waveforms over the course of 5 minutes and see what glitched. It would also be super helpful for when you've got an amplifier that just keeps blowing vets above a certain voltage and you don't know why, and because it happens too fast, you can't really see what's happening in the drive circuit. But having data logging would actually show you the point where the drive circuit glitches or something goes high where it shouldn't, and it would actually tell you what the problem was. Your mic sounds a little boomy. Yes, I agree. You know what? That's a really good shout. Where's Reflow? This is how my live streams used to sound. This is using the JVC mic, which is very tinny. I prefer the sound of the Canon, but that's not Canon. Sorry, the Osmo. But I agree. There is a room mode. So I'm going to see whether we can apply some EQ. So we'll do this together. Let's have a look. Filters on this one. Audio filters. Let's see. Can we do? We've got a 3-band equalizer. Maybe I can just turn the bass down a bit. 1 2 1 2 1 2 1 2. So tell me, guys with speakers connected right now. Tell me, you know, with some bass or whatever. Tell me where's good. So I'm going to carry on talking now, just so you can get a rough idea of where is probably a good point for the low to be at, just to reduce the boominess of this mic. So we're down at like 9-10 dB now minus. I can keep going down to 12, 13, 14, 15. Hopefully it's a bit less boomy. I don't know how much obviously that's going to take, but this is all the way down at minus 20 dB. So let me know what point along this scale is best for how my voice sounds. Let's have a look at some of the someone said it's lagging. Your voice is behind. That's annoying. Is it behind by much? It's not affecting anything. Something's not right. Okay, maybe I need to apply it. Do I need to like close? Maybe that's better? I don't know. Yeah. But how many milliseconds would you say the delay is? I'm gonna have a look at the filters. Maybe there's too many filters on the maybe there's too many filters. Maybe that's why it's causing a delay. Yeah, it's really frustrating. It's like teething issues. This is a new camera that I've got. Wow, many seconds down behind that. Okay, how about now? I've just deactivated and reactivated it, so it shouldn't be delayed anymore. Let me know. Yeah, okay. So yeah, turns out. So let me know if it goes out again. If it goes out, I think what it is. I'm just gonna reset it again. What it is this setup, this streaming setup, is overloading my PC's USB bus by like a lot, to the point where I often get the mouse stuttering and the keyboard stops working because there's just not enough bandwidth, or there's not enough current in the 5-volt supply or that the motherboard is supplying. So I'm going to need some PCI USB cards. All good now, all good now. Sweet. Okay, great. Loving it. Loving it. Loving it, guys. Thanks for your assistance. Try and decrease the mid a tiny bit. Okay, let's see what we can do. Let's go for a 1, 2, 3 like that. How's about that? And then I'm just gonna refresh this again. There we go. So let me know if that sounds alright. But either way, we're gonna get some power wires connected up to this B2. I might also crack a window because it is cooking toasty in here this evening. It's quite a nice evening. It's very windy though. I get a lot of wind, unfortunately, up here. Bring back the lower smidge and decrease the high pitch like a tiny bit. Alright, alright. Let's give that a quick go. What was it? Decrease the high and bring back the lower smidge. Maybe like that. Maybe that's cool. Does that sound alright? Yeah, either way. You don't got air conditioner? Nah, man, we're in the UK. We're in the UK. No one's got freaking air conditioning, bro. You've got like 3 days of hot weather in the summer that you might need an air conditioner, and the rest of the 360 days, whatever it is freezing, and you've got the heating on. So no, man's not got air conditioning, bro. It's a bit quiet now, so try upping the volume to compensate. Oh man, this is back and forth. I'm right. Yeah, it is a little bit quiet now, isn't it? Okay, hang on a minute. Filters, gain. So I'm just going to increase the gain a little bit now to compensate. 1, 2, 1, 2. There we go. Okay, that should be better now. Hello, Simek. How's it going? Reflow says, ah. I had to drop the volume back down. Yeah, sorry about that. Everyone who compensated by turning their volume up is going to be like, I recently bought a Defbon's Doomsday ADD 37800.1D. People have told me they can't handle music and just for burp, otherwise they die. Do you know anything about it? Let me have a quick Google. That sounds like it might be one of these stupid, ridiculous Chinese sound digital clones where they've just paralleled about 1 million FETs together and they're trying to get you like 35k. Let's have a look. Oh no. Wait, is that... It is, isn't it? Oh no. You didn't? Why did you buy this? Brother. Dude, yeah, I'd probably I would probably agree. Yeah, this is a nonsense amp, man. What do you buy that for? If you want like 35k, just get a couple of Paris PW15Ks. If you got it super cheap, then fair enough to have a little play with. But thing is, although you might have got it cheap, when that needs repair, I'm not going to say if, I'm going to say when that needs repair, that's going to be a big repair bill, my friend. That's probably going to be a repair bill that maybe costs more than the amplifier. Yeah, those kind of amplifiers, they just explode on like low volume or doing nothing. Yeah, like turn them on, burp, turn them off. That's it. I'm not saying you can't play music on them. I'm just saying that they're not reliable for music. They're not like a demo, like a long-term amplifier. They're designed just to make a crazy amount of power for like a short period of time. And I'm not saying that they can't make the power for long periods. They have the components, the parallel components inside to make the power for long periods. It's not about that. It's just terrible optimization of the Class D circuitry. They're like on the edge of the limit voltage-wise, and all of the things are just, it's an absolute crap show of a design. And that's why they fail on low volume, doing nothing. Same problem with the base phase Team 15K. Yeah, exactly. Yeah, it's the same thing. Same thing with the GZCA Ground Zeroes version and the B2 Riot 15K as well, and the SFB 13K. Exactly the same. All the same nonsense. Yeah, stay away from it. If you want the big power, go for a bespoke designed board from the likes of Paris, Taramps, even Sound Digital. The Band of Viking's pretty cool. The 15K, the Band of Viking 15K does seem a little bit unreliable, and also there are issues with the MCUs where they're not supplying you with a replacement MCU when the power supply fails. It just sucks. I wouldn't really recommend Banda just because of their business practices in that regard, but. Anyway, we are going off topic. Let's just have a look at this B2. Anyway, so we're not getting any audio apparently from the customer, so let's plug this RCA in here. Channel 1, we've got a 4-channel amplifier here, and really, let's just see whether we can get can we get it in 2-channel mode? Just so I haven't got to plug all the RCAs in. No, we can't. Okay, we haven't got a clone button for front and rear. We've got the gains on about 1/3 there, interestingly enough. Let's make sure that's off. We're on full range on both of these. Oh, sorry, you weren't seeing that. Full range on both of these. Yeah, that's about right. Okay. So let's see. Now, the guy said that we're not getting any sound on any channel. So that's again what makes me think that this is probably an auxiliary supply voltage issue. Let's turn the signal generator on. It's pumping a sort of like, I don't know, what, 267 hertz. There we go. That's just what my meter, my signal gen was on at the moment. So let's just kick it at that. Reject high frequency. So power up and see what we get on the channel 1 output terminals, which is just over here. I'm going to keep the voltage low at 9.4 just to start with, or just a little bit higher, just to start with, just to make sure this thing comes on. Yeah, so we've got 0.9. Oh, 1 point. There we go. And the Class C switching is kicked in, and we are actually getting audio. Okay. So we are getting audio to start with, which is what I didn't want, because I wanted to see the fault present itself initially, but we're not getting that at the moment. Let's check channel 2. Channel 2. Do we have any audio on channel 2? Oh wait, yeah we do. Yep, there we go. Oh, don't plug it into channel 3. I'll plug it into channel 3, my bad. Okay, channel 2. Yep, audio on channel 2. Audio on channel 3, we know it's there, and audio on channel 4 is present as well. So we've got audio at the moment, which is a bit annoying. So this is an intermittent fault. So what I want to try and do is get the amplifier into a state where it is not producing the audio. But like I said, my inkling is these 47 ohm resistors down here, because these cook and they crack the solder joints. So I suspect that might be the problem. Let's give the board a little knock around while we're plugged in and tested here. Okay, no, it's not cutting out there either. Let's give the high pass, low pass filter switches a little wiggle around. Nope, so they seem pretty okay. Okay. I wonder whether the issue actually for this guy is not his amplifier and it's something else in the setup. I am going to reflow those 47 ohms because they are a common point of failure that would cause this exact issue. So I'm going to reflow those anyway. But yeah, it was working straight away, and it's not kind of cutting out when I knock it around. So. Sign with, where's my black screw on my Big Boss 8? Say what? Your mic sounds a lot better now. I can hear you speak without all the boominess. Oh, great. I'm glad we got that sorted, man. Thanks for your assistance with that. Funny question, do you think the extra PC fans I have laying around will be able to cool my amps like any other fan will? Yeah. A fan's just a fan, bro. Especially like 12-volt fan. The thing that you'll need to bear in mind, not flummoxed, is that fans are designed for use on 12 volts, and depending on how well built the fan is and how much headroom it's got in its design, it may or may not be reliable at like 14 volts, 14.5 or 15 volts, whatever you're charging at. So if you're connecting a fan in your vehicle and it's getting like 14 volts or above, then just bear in mind it may have a limited lifespan depending on the brand and the quality of fan. But there's nothing, yeah, absolutely. PC fans work fine in car audio for the most part, no problem at all there. I think you want to bear in mind is that you want your fan to be blowing air across where the heatsink has the most surface area. So the heat from your amplifier is radiated away from the case like this. So see here, the MOSFETs are clamped to the case. So you don't want to be blowing air inside the board and the bottom here. That's not going to be any good. This is what's radiating the heat away. So if I was going to be adding fans to this, I would want some fans blowing air across the top or these side fins. These side fins would be best because that's where the MOSFETs are clamped to, that's going to be generating heat. So yeah, you want some fans blowing air across these fins on either side here. And you don't want to put the fans on the amp either. Fans work best when they can draw air in from around them and accelerate this surrounding air. You get a much higher airflow. So you want the fan situated a distance away from the heatsink here that's allowed to then accelerate air alongside it, and you'll get much better cooling performance like that, rather than actually if you stick a fan on here, it's not going to do much at all. Is there a screw missing from your amp, bro? Well, from the back? Maybe it fell out in the shipping? Or is it from inside? No, hang on, I didn't take the board out. Must be from the back case. Weird. Get 50-15s. Are those massive kind of fans that have like ducting on the intake and the output? They do move a lot of air, but they're so noisy, bro. I went from a Taramis HD10K to a Powerhouse 10K. Sekiro, what was your experience like going from the HD10K to the Powerhouse? Like, did it sound better? Did it sound worse? Was it louder, more powerful? How was that different? I'm interested to hear from you actually, because they actually both make similar power, and the HD10K actually makes fantastic power. You just need to filter it correctly, the preamp side. Hope you're good, Shane. Yeah, so anyway, I'm going to reflow these 470 ohms because they are an issue on these amps for sure. Just having a quick little visual inspection just to see if there's anything elsewhere as well. I think we're good. I think it's just going to be these. Jay Holly, how's it going, bro? Why does it look so discoloured by those resistors? So it looks discoloured by the resistors because these run stupid hot because it's a poor design. And it's discoloured by the FETs because these have blown at some point in their life, and it's just left a bit of soot and whatever on the board from where those power supply FETs have blown. And it's kind of discoloured the board from the heat. So that these white boards, they kind of turn a bit orange and browny when they get hot. So that's just from that. Reflow. So this amplifier here actually is another one of the reasons why I want to upgrade my oscilloscope to one that has data logging, because if this is an intermittent fault where the audio kind of cuts out sometimes, I don't want to be sitting here on the bench looking at it for freaking 2 hours waiting for it to cut out maybe. I want to just stick it on a power supply, playing a sine wave, and have my oscilloscope connected and have it logging the sine wave output, have it basically recording that over the course of like a couple of hours, and then I can come back and just like skip through the data, skip through the waveform, and see if it drops out at any point. That's what I need to do with this one. So yeah, kind of annoying when you get ones in like that. So let's power it up now with a full. Let's go for a full 14 volts because that's what the guy will be using in his car probably. We don't have a load connected, so this is Class D. We do need to be a little bit careful. We don't want to send out tons and tons of voltage on the RCAs, but yeah, let's power it up and see if we still get output on channel 1 here. Ha! Interesting. We don't now get output at the higher voltage. Okay, so there is something going on here. Now, I don't think we've got Class D switching either, because the idle current's too low. Nope, no Class D switching. Ha! Alright. Does the Class D... Ah, there we go. If we knock down the voltage a little bit to 13.3, now we get the Class D switching. But when we go up, does it stay? Yeah, it does. Okay, power off. And power on again. He said when you power cycle the amp, it's... Ah. Yeah, okay. No Class D switching initially when powered up. Now, interesting. That is definitely something. And that's across all 4 channels as well. So because that's across all 4 channels, that's going to be related to auxiliary voltage supply circuit. So that's going to be one that creates... I don't think it's related to this circuit I just reflowed, although they do go bad. I think that's going to be the 12 volt ref negative rail circuit, which might be... We got rectifier diode here and here. Might be... We've got this one, Q1 over here on the board. Oops, wrong button. We've got Q1 over here. That could be the 12 volt regulator for the output drivers. These two are 15 plus minus 15 volts for the preamp circuit, so it's not going to be that. So let's power it up and see what we're missing. So we're going to take a look at the output driver card, just one of these. We're going to probe to see what we've got on the 2092s. Make sure we've got our supply voltages, etc. Let's bring up... Is this 2092s? Was it 20957s? Hang on a minute. ROS 2092s. Yeah, 2092s. So let's pull up a data sheet for the 2092 just to remind ourselves. And let's have a look at the example circuit, which this is pretty much going to be based on anyway. We have VCC 12. So VAA is usually about 5 volts, thereabouts. Might have an issue there actually. That's going to be coming from... well, in the example circuit. This is not a schematic, by the way, so don't at me about the title. This is the data sheet for the 2092. This is an example circuit. This is not necessarily the same as what we've got here, but it's probably very similar. So yeah, the VAA is usually around 5 volts, and the VCC is going to be 12 volts reference to negative rail. So let's go ahead and compare pin 12 to pin 10 and see if we've got 12 volts above that. So pin 12 and 10. which is the second and fourth one up. So this is our negative rail, which is COM. Oops, let me do one of these ones so you can see on the camera. This is comms. This should be negative rails. Let's power up. So we got negative 47 volts there on the scope for our negative rail, which is ground reference for this amplifier. Now if we go along to this pin here, we have, oh yeah, okay, we got negative 34 volts. So yeah, we do have 12 volts ref neg rail in there. So we've got VCC. Do we have VAA, which is this bad boy right here? We've got 5 volts. Yes, we do. We have 5 volts. Okay, so we have our supply voltages. So what's missing then? Let's have a look at the data sheet again. So we're going to need, so pin 3 is our input, and these 2092s can accept a audio sine wave. Inside the 2092, it does the Class D sort of PWM conversion inside the chip, so you don't need an external Class D like pulse converter or anything like that. It does all that internally, so we can feed it with a sine wave. You can inject these 2092s with a clock signal as well to fix your output switching frequency rather than having it self-oscillate. So we might have something like that going on here. We can investigate. VSS should be ground, should be 0 volts in this case probably. Although in the example circuit we've got it referenced to negative rail, but I think we're just going to have ground here. VREF. That's going to be a internally generated 5 volt supply most likely by the 2092. And then we've got a voltage divider on the overcurrent set. We can inspect those resistors, make sure they're okay. But then up here, pretty much, we've just got dead time, which doesn't matter what that's set to for oscillation. And then VCC we know we've got. VS, we're not going to get VS until we get some Class D switching because that's a high side supply and reference. So CHS could be could have something on there. So yeah, I just want to check a couple of things. I want to see what we've got on pin 3, and I want to see what I want to make sure that we've got that CSH is. Do these have a shutdown pin? Oh, CSD. CSD. Let's check CSD as well. I skipped over that. That's the shutdown pin. So that's going to be if that is high, I believe. Hang on a minute, let me think about this. If CSD is low, I think it goes into shutdown because we have a capacitor here on CSD, a timing cap. So basically CSD, that's going to be internally pulled up through a high impedance probably, so it's going to rise slowly. So the capacitor across CSD and VSS is going to present a low resistance obviously while the cap is empty. So then CSD is going to ramp up slowly because of that capacitor there. So when CSD is high, the chip should activate, and when CSD is low, the chip should be in shutdown. So let's just have a look and see what we've got on pin 5. 1, 2, 3, 4, 5. Okay, we've got negative 5 volts there. Huh, that's not what I was expecting to see. Let's turn the voltage down from 14 volts so we get this amplifier activated. Let me just power cycle and go down with the 9 volts because we know that it was working at 9 volts here. Negative 5 volts to start with. Okay, we still actually don't have operation. So it's not related to input voltage per se. Still don't have any operation here. Oh, now we do. And CSD has now all of a sudden ramped up to 5 volts. You see that? So it was at negative 5, and then when the amplifiers come to life, it's just come up there to 5 volts. And then when we remove the remote, it's down at negative 5. I'm not used to seeing the CSD go into the negatives, but I mean, maybe. Okay, let me check the voltages on some of these other pins here. So VAA we already know is 5 volts. Ground obviously should just be ground, which it is. That's cool. And in pin 3, we should have like input, which is going to be our sine wave. I don't know if we've got the signal turned up much at the moment, but let's have a quick look. So we've got about 0.7 volts there. No Class D switching yet. Let's move the... okay, now we have Class D switching, and we're down at 0.2 volts. Okay, so that is a little different, but that's fine. Pin 4, the comp pin. Let's have a look, see what we've got on there. So initially at power up, we get negative. Oh, okay, so that's why. That's why we have -5 compensation is down at -5, which the CSD I think is referenced to. So if we fiddle about with the voltage again, now that's really interesting, isn't it? When I touch the voltage, it then suddenly comes into life. So it's got something to do with either the movement of the voltage on the supply line or the movement of the rail voltage. When the rail voltage moves, it's kind of kicking it into life for some reason. Very strange. Okay, so yeah, comp is moving from -5 up to sort of a little miniature triangle wave there. Pin 5, we already know what that does. Pin 6 is VSS. So that should be ground. Right, that's -5. But then when the amplifier comes to life, that's still -5. Okay. Okay. It was -4.7. So we got ±5 on VDD and VSS. I'm pretty sure I'm used to seeing VSS being ground, but okay, no worries. I guess they have literally, I reckon that this is actually an exact copy pretty much of the example circuit. So that would make sense. If we've got a tracking supply on VAA and VSS, that's going to be referenced to the rail voltage here, B plus, B minus, and then just got a little resistor in line to drop that down to 5 volts. Same with the negative rail to drop that down to 5 volts there. Now, what this could be one faulty 2092 chip, because I imagine all of these 2092s probably have their CSD pin paralleled, so that if one chip or one channel goes into protect or triggers protect, then they all shut down. So if one of these chips is a little bit faulty and is triggering the CSD to go low, I think in this case it would be, or go high, whatever it is, then it will be shutting them all down basically. So let's just wait for the rail voltage to sink down a little bit to reduce itself. We're already super low. Nice. I just want to confirm with my suspicions there that 1, 2, 3, 4, 5 is in fact all in parallel or connected somewhat. Doesn't look like they are. They're not directly, at least. There might be a high value resistor in between them. Pin 5. 1, 2, 3, 4, 5. Yep. 1, 2, 3, 4, 5. So we have, what do we have on the multimeter? We're in diode mode. Let's go to resistance. 1, 2, 3, 4, 5. How strange. Usually you'd have all of these CSD tied together, because if one of these trips into shutdown, you kind of want all of them to, because it means there's something going on funky. But they're not. There's no, unless there's a diode maybe, but there's no resistance between these CSD pins here, which I have definitely seen before. We've got 925 in diode mode one way round. If we flip the probes the other way, we've got an open circuit. So we've got a diode of some kind, whether it's an intended 925 that way, and yeah, we've got 925 worth of voltage drop, but a very high resistance it would seem. Okay, I have a little suspicion. I'm a bit suspect of this black glue. You see this black glue in a lot of home audio plate amplifiers and stuff, and it causes issues because it goes conductive over time. So I'm just going to heat it up a little bit and actually remove it from the circuit, because actually it can cause issues. And just while my hot air gun is heating up, I'm going to take the multimeter, I'm going to switch it to very sensitive resistance mode, 2 mega ohms, to the point where I can touch my fingers and it reads my body resistance, so it's very sensitive. I'm just going to stick the probes into this black stuff just to see whether it's conductive at all. Like, it doesn't actually look like it is yet. We've got a little movement there, but I think that was just me touching by accident on these. Okay, so it's not reading as conductive, but it's still, because it gives off fumes, it can actually be eroding these solder connections underneath it. So we're going to heat it up a little bit and just lift it off those components that it's covering. Straight up kicking the nuts. How's it going, buddy? Good to see you as always. Let's read a little bit of live chat while we're cooking that up. Blah, blah, blah. That has a lot of surface mount components. Discrete surface mount, clean the sound. True, although all of the actual audio stuff is integrated circuits from 2092. Basically, you've just got a preamp circuit with op amps, and you've got that being fed into the 2092s, and they're doing the whole Class D drive and conversion. So it's, I wouldn't really say it's a discrete amplifier at this point. What's up, Delta? Imagine a speaker with a 1000 coil versus 2 but higher ohms divided... Wait, what? Sorry, Adam, I'm not sure I'm understanding your question there, buddy. Is this a B2 amp? Yes, it is. Why did you give up on the lens on the Litz wire coils like your Mr. Wizard friend recommended? So basically, for the frequencies that I was going to be dealing with, the Litz wire was unnecessary and very, very expensive. Yeah, that's what we basically decided and worked out. I hope he's doing alright, actually. My good friend from that video, from the Audio Pipe Part 2 video, Mr. Anthony, he wasn't in super good health of recent times, so I should find a message, see how he's doing. Anthony Volkman. That's the guy. Late to the show, but at least I can catch the rest. Yes, you can get Jared. We haven't actually moved on to the main event. This little B2 amplifier is taking a little longer than I expected. I thought this was just going to be a nice little quick auxiliary supply voltage reflow, but no, it's kind of cutting in and out here. Yeah, Anthony definitely knows his stuff, man. He's a little genius, that guy. So basically, someone on my live stream on Monday asked me, why don't you see amplifiers designed and built using those massive IGBTs that like take up the whole palm of your hand that you see, and that are used for like traction inverter, motor inverters for like trains and stuff. And he actually has been designing a super high voltage amplifier using those IGBTs as the output devices. The thing is supposed to do like 150 kilowatts, or like maybe even more, like maybe like 300 kilowatts or something stupid like that. Yeah, he's been really into designing that, so I wonder how he's getting on with it. John says, I have the HD3000 and really like it. Yeah, it's a great little amplifier, especially if you feed it with a decently low-passed signal. It's a great little amplifier and it sounds fantastic as well. The switching frequency is nice and high compared to some other Class D amplifiers out there. It's a full bridge, so you got low floor noise, and you got no bus pumping either. Damping factor's okay. Yeah, it's not a bad amplifier. It won't take the kind of abuse that the bass line will do, or the smart line, but provided you're keeping it within its recommended minimum impedance, it's a great little amp. I've seen a lot of repairs on KRK monitors. They're known to go bad because of the conductive glue. Yeah, for sure. It's a super big issue for some reason in like active speakers or like that kind of hi-fi home theater kind of products. One amp for 2018s. Yeah, exactly. You have to get creative with some series parallel wiring, but yeah, it would be pretty cool, wouldn't it? Right, let's. I know it's not fully removed, but let's just see whether that's made any difference at all. I'm actually not super confident that this is the problem, but it's the first thing to try because it's a known issue, and it also means that removing these driver cards are actually in headers, so they're hot swappable. No, not hot swappable, but you can remove them, yeah, and put them back in easily. So that way we can actually identify whether the problem's on one of the driver cards or not. You see the glue actually spills down onto the main board here. Let's just remove this for a sec. I think it's slightly glued in, so yeah, let's just take that out there. So the glue actually spills down onto the main board. So yeah, there might be a component under here that's kind of getting a bit screwed up by the glue. So we'll see how it goes. Let's just remove that one. I'll just check some of the components underneath the daughter boards as well here to make sure that nothing else got too hot under here. I think we're okay. Nothing standing out to me immediately. Got to make sure that these go back in the right way around, because I think the headers on either side, the pin config is the same number of pins, which is a bit dangerous, isn't it? Okay, I don't think that's probably made any difference, but let's just check anyway. So we're going to start off with a low voltage. 0.9 amps. And doesn't look like we've got any Class C switching. Nope. Now we have Class C switching. So yeah, still have the same problem. Okay, what I'm going to do is just let the row voltage sink down again. I'm going to remove one of these cards at a time and power up, and just to see whether one of the drivers on these cards is kind of pulling the CSD low, perhaps. Okay, the row voltage disappears really fast actually in this amplifier. So let's take that one away first. Let's power up and see if we get Class D switching on this channel here. Let's go down to 9 volts again. Okay, so same issue, no Class D switching. Yeah, it definitely should have initialized by now, so it's not that. Damn, the rail voltage freaking disappears, doesn't it? Does that mean we don't have any rail capacitance? So amplifier on, amplifier off. No, we've just got really low value pull down resistors. The rail voltage disappears very fast. And then let's try this one. Okay, still same issue, no Class D switching until we mess around with the voltage. There we go. Interesting. Right, so let's pop this all back in. So we definitely have a problem on the main board. Now what I'm going to do is I'm actually going to leave these out, okay? And what I'm going to do is I'm going to look for some differences in voltages on the headers here for these driver cards, initially after power up and then after fiddling around with the voltage, just to see if anything changes, because honestly, the issue is clearly on the main board here somewhere. So I'm just kind of curious to see what changes on these headers when the amplifier comes on and doesn't. So on this pin we've got a whole deal of nothing. Let's try this next one. Again, nothing there. Third one. Oh, that's interesting. That is some kind of protect signal, I think. So when I probe it, is not happy when I probe that one, goes to protect. Okay. Well, the amp's not going into protect, so that's not going to be the issue. Pin 4. Okay, that's not doing anything. 1, 2, 3, 4, pin 5. Negative 25. Now that is obviously moving with the rail voltage. That's probably going to be our 12 volts reference negative rail. Yeah, 27. Okay. Next one along. That's going to be our negative rail itself. Next one along. That's nothing. And lastly, the end pin. That's negative 30. That's kind of somewhere in between. Negative 38. So with 12 volts, that is negative 38. Power off. Now this might have something to do with it actually, because the voltage is kind of walking a little bit with my movement there. Okay, let's try this other set of headers over here. So while it's powered up, we have, what do we have? A little bit of noise on there. We have a sine wave. Okay, so that's our audio input. Power off. Power back on. So that does wobble a little bit with movement of rail. Second pin here. That looks like negative rail. 38. Okay. Third pin. That is negative 5. And that's pretty solid. That is pretty regulated. Wait for that to fully disappear. That's still present actually. There's a capacitor holding that high. Amplifier's been off for a while now. Okay, now we're starting to slowly sink down. But that's not being affected by the movement of the rail, so that's fine. That's the third pin along. Fourth pin. It's probably a ground. That's nothing. Okay, fifth pin along. That's also seemingly a ground. Not doing anything. Sixth pin. We have 6.1 volts with a bit of noise on it. That seems relatively stable. Well, it does move around a little bit actually with my voltage here. I wonder what that's for. That's our negative rail again. And this last pin. Just a lot of noise. So we're not really, I haven't really found anything on the main board here that like drastically changes from powering up and moving the voltage around like it does when we actually have these driver cards connected. The one that's got me a little interested is the 6 volts that we saw on, I think it was the third to last pin. So I'm just going to go ahead and see what that one is with the driver cards fitted. I think it was this one. Yeah, I've got 5 volts now, so it probably just needs pulling down a little bit. But yeah, no output, and all of these seem to have the comp and CSD low. Okay, this is definitely our issue. Something is keeping, so basically these 2092s, the CSD has an internal pull-up. So if it's being held low, it's being held low by something externally. So that's what we're going to have to trace and try and find where the issue is. So let's go and zoom in on one of these driver cards. The issue is almost definitely going to be on the main board though, because yeah, it's happening regardless of which one of these we put on. So pin 5, let's just see what we have. We have continuity to this resistor. I can see the trace. So we have continuity into a 100 ohm resistor here. Let's confirm. It says 146, but that's because we're on diode mode, so it reads a little high for some reason. So I know that that's actually reading 100, that's fine. If we go to this one as well, we should have the same. 1, 2, 3, 4, pin 5. Should have another 100 somewhere. There we go, there's a 100. On the other side we should have a 146, there we go. So on the other side of that we have a diode, D11 in this case. So let's just check the diode. We have one way round reading 1358 and the other way around we are reading 560. That's what we want to see, that's the diode reading basically. 560, let's just check that we have the same on all of these. 560, yep. 560, 560, okay, so after the diode, where does the trace go? The trace goes into this little via, and then does it go to the main board? It does! We have it going to pin 2 here, and also this second pin, interestingly, and that's all parallel. So you know when I said the CSD pins are all going to be in parallel? They are, there's just a series diode and resistor between all of them. So, interesting, pin 2 and this pin right here, that's our shutdown signal basically. So let's probe that and see what we've got on that when the amplifier is trying to power up and come to life. So initially we have a negative 6.5, and then if we glitch around with the voltage on the power supply here, there we go, then it suddenly whoop comes up to 5.1. Okay. So if I remove these driver cards once more, because it could be paralleled on the board itself, I want to find the actual origin of that signal. Hooray. So are they paralleled on the main board? Don't know if my thing's actually going to stick down in there, so I'm just going to get a little bit of component leg and stick that in there like that. Same for the other one, because my multimeter probes are too damn thick. Okay, we are paralleled on the main board as well. That's cool, that's fine. So let's just leave one of those. So where do you go on the main board then? I wonder whether you got this black glue stuff something to do with it. Let's turn the power supply off just in case there's any battery supply coming over this way. Over here, I got a sneaking suspicion that we might have something underneath this black glue. Potentially, in which case we need to remove it. Let's also check over this side, because obviously they're all going to be paralleled, so the circuit could be on either side of the board. Looks like it's got a bit toasty over here actually, do you know what I mean? Not finding any continuity yet. We might have to do the the old wire brush trick. This is a bit sketchy because if there is any voltage floating around in the board still, like any 5 volts in a cap, then we can short that somewhere where it shouldn't go. So I'm just making sure that there's no like voltage anywhere. Oh wait, I just saw we did have yes, we've got a little bit of voltage there sinking down. So what I don't want to do is start like shorting everything together when there's like charge caps still in the board. 3 volts, I'm sure it's fine. So what we can do is take our wire brush with the multimeter probe stuck in one end and go hunting for continuity. Well, there we go, got something over here. Alright, so let's go and turn our attention to that area. Maybe it was a via. Oh, there we go. And that goes round to... where does that go? It goes under this black glue stuff. And I can't actually see where it goes from there. So I might need to remove that black glue, see where that trace goes. Go. So now we should be able to see where that trace actually goes. That's this one here. Goes around there, down here, there we go. And now we haven't actually dismantled this from the case, so I'm not able to follow that underneath the board, so we're just going to have to try and guess again where that goes. It might actually even go over to the power supply circuit here. There might be like a timer over here. Let's take the old brush again. It's a bit of a big brush, so it doesn't really super fit in everywhere. But we're touching like all of the bloody pads over here, so we know that there's no continuity anywhere over in this circuit here. What we haven't been able to reach though is this little circuit over here. Don't think we was able to get over into the nooks and crannies over here. Okay, so the trace goes there. Where does it go? Where does it go from there? It's going under the board, so it's either going to go across this way towards the power supply side, or it's going to go... where else would you go? We might have to remove the board from the case here, just so that we can actually follow it underneath. It'll be annoying because obviously everything is surface mount, so the issue is definitely fixable without having to do that. Brush method is hilarious. Bro, it works! Isn't it? It just works. Cleans the board and finds your trace, exactly. Yeah. Do well. Check it now you remove the glue. Yeah, that's a good idea. We're going to check it after we've removed the glue, because there's definitely some components under here. I don't know if these components are to do with the CSD timer, but yeah, it might do. Worst case, if we honestly can't find the issue, like we will be able to find it, but if for whatever reason you just wanted to get the amp bloody working and you couldn't find the issue, what you can do is actually just disconnect the CSD. You could lift all of those resistors, those 100 ohm resistors, just lift them off their pads, and that will mean that the output drivers come straight to life the moment that the amplifier receives its supply voltages. So obviously, yeah, that's something you can do. Is it advisable? Well, not necessarily, because it means that the amplifier can't actually, well, you're not going to get any, what do you call it? You're not going to get any soft start. So the amplifier is going to come to life immediately. You might get a little pop, but also you're not going to have the output drivers shut down in event of a failure. Although the power supply will shut down, so they will turn off. But yeah, it's just not super ideal. So I'm just curious. Do those go anywhere over here? Has that got anything to do with it? I doubt it, but just kind of interested, curious to see. No, I don't think so. So I don't think that's going to have made any difference, guys. But you know, it was probably a good idea to do, nonetheless. So we'll test it in a minute now that we've removed that glue anyway. But yeah, I do just want to find where this freaking trace goes, because that's where our issue lies, guys. Our issue on this amplifier is in the CSD timer circuit. So just got to find it. I know we got a beep there, that was just off of my header. Again, that's just the bristles touching the multimeter probe there. It could even be a dodgy via. You know what? I've just thought it could even be that this via is bad. I think I'm gonna have to bloody remove it from the case so I can follow the trace. I think that's what we're gonna probably have to do, because I'm not having much luck here finding it by pure chance. Wait, here we go, found it. We have an optocoupler over here. Okay, optocoupler. Optocoupler could be bad, or signal going to optocoupler could be bad. So let's put the output driver cards back in place, and now let's start having a peek over at that circuit, because that's where our issue is likely to be. So power, 10.9 volts. Let's power it up and just probe the low side drain. see what's going on now we remove the glue. Like I say, I don't think that glue's got anything to do with it, but yeah, I'm just kind of curious to see. Nope, still no operation, so that glue does not have anything to do with it. So let's hone in on this optocoupler then. So we know that that has continuity to CSD, so that's going to have negative 27. And then it jumps. Yeah, okay. Okay, look at this, look at this, look at this. So on this pin, this is the pin that we have CSD. So we've got negative 6.8, and then it jumps up to, oh, guys, it jumps up to 5.3 on the optocoupler, but at the via, we are up at 5.3, but we still don't have any output switching. 1, 2, 3, 4, 5. Huh? Well, this is now behaving different. CSD has now gone high, but we still don't have any output switching. Reset, that should have fixed it. Blah, 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 blah. So anyway, so this has kind of just changed its behavior a little bit, because now we do have our +5 on the CSD, so the chips aren't being told to shut down now. So we just trace that all the way back, but our pin 4 is at -5, and if we mess around with the supply voltage, is that going to go high? Huh, no, weird. Now the amplifier seems to be like fixed off. No matter how much I play with the voltage now, it doesn't come to life. I think we actually do have dodgy vias here. I don't think it's the via that's on the CSD line, but the way that this is behaving is giving me all the signs of dodgy vias. Because now I can't kind of kickstart it to life like we did by messing around with the voltage. Interesting. Interesting. So CSD, the comp pin 4 needs to be high, but it's not. Did you swap the driver boards over without realizing it, hence the change? I don't know. I did remove a lot of glue. Yeah, I did, but removing the glue shouldn't have made it worse, should it? So let's, just out of interest, swap the driver cards over. I mean, we have swapped the driver cards over again before, and it didn't make any difference to the fault, but yeah, just out of curiosity, let's just do that again anyway. See if that makes any difference. So pin 5 we were having issues with before, but now seems okay. -5.6, and that should go up. There we go. Yeah, it goes up to 5 volts, but we still don't have any class D switching. And if I mess around with the voltage, we're not getting any now either. Although what's interesting is, we're not getting any sine wave input now. Huh. Didn't we have a sine wave input on pin 1 of this header? We're not getting it now. Are we getting bipolar ±15 volt supply? That's going to be here. We have +15 and -15. Is that making its way over to the preamp board? -15 and positive. Okay, so we are getting our bipolar supply there. No sine wave input there. Nothing on pin 2. Pin 3, -4.8. 4, 5, 6, we've got 5. 5 there. Huh. .2, 1.2, 1.2. So CSH is 1.2 across the board. We've got +5 there, and VSS -5, plus 12 volts above negative rail. Just make sure we still have all of our reference voltages. Negative rail is -41, which we have, and VCC is wait a second. Now we've got a different fault, gentlemen. I think we have a different fault now. All of a sudden, we've not got our supply voltage to the output drivers on the VCC side, reference negative rail. Going back to our data sheet here, right? Pin 10 is COM negative rail, which is -41 volts, right? So pin 12, which is this one, should be 12 volts above negative rail, which it in fact is not. It is at -40, which is 1 volt above negative rail. So we've got compounding faults here. All of a sudden, we've lost our supply voltage to the output drivers. This is madness. This is like a proper kettle of fish. What's going on with this thing, bro? Whoa! Right, where does that come from? That's going to be generated over here. I almost guarantee it. At this transistor, probably. So let's just... I shouldn't have powered the amp off, actually, should I just then? Let's just power the amp back on again. And let's just confirm over here. We have... Right, now we're getting it. Now... And then it disappears. Whoa! It disappears. So initially, when we turn the amplifier on, we do get 12 volts above negative rail. See that? 31 volts. But then as soon as the amplifier tries to initialize Class D switching, that 12 volts disappears and jumps to pretty much negative rail. So that means that there's a higher resistance along the path of the 12 volts reference voltage. Now, I think the 12 volts ref negative rail is generated over here on this transistor. So I'm actually just going to go ahead and remove this this clamp here, because I want to take a peek and be able to get in there better. Oh, Connie, have you forgotten something? Your ads, we want to support them. So that's an interesting question. Oh, hang on, mic delay again. Let me just quickly reset this. So for this stream only, I set the monetization to give you ads automatically, randomly every 24 minutes. So has anybody had an ad yet? Let me know. And it was after all the spit from you put on the board after me saying yeah. Thank you, Sam, for the Xenon help and reminder of the muting delay. Oh, no worries, man. I'm glad that was useful. Every time he gets excited, the mic goes out of sync. Maybe it's when it clips. If I clip the mic, bop! So now, has it gone out of sync? I've had ads, yes. Okay. Oh, cool. You have had ads. Good. That means I'm actually making some money from this stream. Good. Anyway. So yes, over here we have this little transistor, which is a TIP41C. TIP41C. So let's have a look and see what we've got on this transistor when the amplifier tries to initialize. Alright, 12.8 volts going in. Let's just turn that down a little bit. Okay, so power up, and let's just confirm which one of those pins is actually in line with the supply. Okay, so this end one here, we've got 10 ohms between this end one and our drivers. So if we probe there, we should get, obviously, yep. And then when the amplifier tries to initialize, it jumps to negative rail. 31. 17. So the issue, you know what it might be? This TIP41C might actually be bad. because why else would... So this isn't a normal kind of voltage reg. This is using a Zener diode here. So we've got a Zener here on the board. Okay, and that's going to be supplying a reference voltage. So we've got our negative rail. I'm going to go back up to 12 volts because that's what I remember the voltages as. We had negative 41. So we should have negative 41 here. And we've got negative 37. Is that actually negative rail? Hang on. Negative rail is at... okay, negative rail is at negative 39. So a negative 39, okay, on there, which should also be there. Well, it's actually not. It's a little bit less. Negative 37. And that might be... that should be an issue. And then on this middle pin, we've got negative 20, which is going to be about 17 volts above negative rail. So that's the input, is 17. And then the output here, we've got... Well, it should be basically that, negative 30, which is about 10 volts. So yeah, this circuit is the problem here. So we've either got... It's either this Zener that might be bad. So you know what? This Zener doesn't really have much voltage drop across it. We've got 30... Is that Zener bad? We should have a bit of voltage drop across that Zener, shouldn't we? Negative 20... Negative 37... Oh, Matthew, thanks for the 10, dude. Appreciate you, man. Thank you very much. You don't have to do that. Apologies for not wanting to turn my blocker. No, I highly recommend ad blocker, guys. Don't worry. If tip 41 was bad, it would be bad all the time. I don't know. I've seen transistors go a bit funky like this before. Okay, let's power this off and let's just take the multimeter and check across the Zener here. So we have 365 one way, and we actually have low values both ways, which is not really what you want to see. On the tip 41, that's reading okay based on the multimeter for what I would expect. 1031, although maybe not. Okay, let's because we've honed in on the issue here down here. So what I'm going to do is I'm going to pull the Zener and I'm going to pull the TIP41C and we're going to drop both of those in the tester. See what they say. It might also be a good idea just before we remove the Zener, just to get a reading off it, just to see what the markings are, so that we can guess what voltage it should be. It's probably like a 12 or 13 volt Zener, something like that, because we need 12 volts above negative rail. So let's have a look at the old microscope, eh? See if we can get... okay, so we've got H2 on the Zener. There, you see that? Just about. H2. So if we go to our favourite website, S-Manuals. S-Manuals. Love to see it. smanuals.com. And we go to marking SMD and we go to, what was it, H2. So we go for H2 and it's a 123, which is a Zener diode, which is this one right here, which is a H2. That is a nominal voltage. Yeah, it's a 12 volt Zener. Easy. 12 volt Zener. Boom. So, okay, yeah, let's just reflow these parts so that they're easier to remove with a hot air gun. This Zener here, for example. Let's get that reflowed with some 6040 leaded solder. I'd love to see it. And I'm also just going to reflow these pads a little bit here. And this transistor should actually just lift out. It's like low thermal mass PCB. Easy. I was hoping to get onto these Camco amps tonight, but you know what? I don't think I'm going to get time. This B2 is proving to be a little bit of a pain in the butt. Okay, there we go. So that's out nice and easy. And then let's remove the Zener as well. If I was American, I'd probably say Zener. Let's remove... I can't do a bloody American accent. Let's remove the Xena diode. There we go. Alright. Let's get our trusty MK328. How you doing, sir? Oh, I don't have much reach on this tonight. Okay. What are we saying then? So, what's your guesses, guys? 41 bad or Xena bad? Okay, so the 41 reads fine. We've got an NPN transistor, HFE 155. Yeah, it's fine. So, if anything is going to be bad, it's probably the Xena. And we were actually reading a dodgy value, weren't we, across the Xena just now. So, let's just see. Okay, well, it's reading as a capacitance. I might have to actually solder this to the tester. I was trying to push down with my finger, but it was reading my finger capacitance instead of whatever the diode is supposed to be. So let's just drop that on the tester. A little bit of hot air. Oh wait, I don't even have this turned up. Huh. I had this, the hot air gun calibrated for bloody, doing the glue. I didn't even have it at the right temperature, but somehow it actually melted the solder well enough on the, on the board to remove it. Interesting. There we go, that's better. Yeah, I only had the hot air gun set to like to about 230 degrees Celsius, which is hot enough to melt solder, but obviously that's just the temperature of the element, not of the air coming out at the end. Delay. Has the delay been sorted? I'm going to limit the color range as well, so I won't look as nice now, but hopefully that stops there being an audio delay. Yeah, it's just my USBs are overloaded, guys. I'm going to fix it. I'm going to get some USB PCIe hub. So let's see what you're saying. Ah, there we go. There it is, guys. This Xena diode is a 99 ohms. Ha! Mustard or ketchup? Let's grab ourselves a replacement 12 volt Xena. I might only have through-hole Xenas, but these pads are big enough, it's probably fine. Do you still check Discord? Nah, man, I can't keep up with all the different socials. What are you? 15 volts. I can't remember what a lot of these are, but we're going to go, I think probably what we should do is, for reliability, we should go for a nice big powerful through-hole 12 volt and just solder it to the pads. What do you say? What do you reckon? This is a 36 volt. This is a 5.1 volt. Here we go, 12 volt Xena. There's some chonky boys in here. There we go. This ain't going to be dead anytime soon. How's about that? How you doing? That'll do. Because seemingly that might be stressed a little bit more than the circuit was designed for. So that should prevent the issue coming back. Okay, where's my choppers? Where's my choppers? Right, here we go. So let's get that on there. Let's chop that leg off. Keep that to one side. Always keep your component legs that you chop off to one side, because they're super handy for all sorts of stuff, jumping over bits and pieces, etc. bend that like that, bend that like that. Now, is that the right kind of size, or do I need to go smaller? Okay, I need to go a bit smaller there with the leads, if I can. Si possible. Bend them slightly in on themselves. There we go, okay. Okay, yeah, cool. Just trim the end off that a little bit, and then I'm actually probably going to solder this with the iron rather than the hot air. So we can either lay it like that, or we can probably mount it up against the capacitor maybe. Yeah, I prefer it that way around. There's nothing on the board there. That's good. Bit of flux and some solder on the tip, and we should be good to go. I just came in, Sam. Is the current limiting resistor for the Xena any good? In what context, bro? I'm not sure I get the question yet. There we go, not as pretty as the original, but functionally much better. That Xena might need a higher current. Definitely check the upstream current limiting resistor. Okay, no worries. Give that a quick look. Let's get the 41C back in. Go on, just go in first try. Don't make me mess around, please. The audio delay is triggered when switching to the main camera on. Yeah, we shouldn't have this for too much longer, guys. When I get the USB hub, it should be sorted. There we go. Okay, and a little bit of isopropyl. Let's clean that off a bit. Get a hub with an external power brick. Yeah, that's the plan, or I probably won't get an external hub. I'm just going to load up my spare PCI slots with USB extenders, you know, USB PCI things. Alright, cool. So I hope now that's it. We haven't really done much, to be honest. We removed some glue. We traced back the issue on the CSD, but that sort of seemed to sort itself out. But maybe the main issue was this Zener all along. So let's go and power this up. Yep, check there's no like solder flakes anywhere. So let's confirm on the 12 volt line we should get 12 volts reference to negative rail. Go for, let's just start off nice and low. I'm going to put a second probe on negative rail so we can see it on the scope together. So one of these probes is going to be negative rail, the other one is going to be the 12 volts. There we go, so it's stable there. And then yes, we do get class C switching because the current increased to 1.6. And that is now stable 12 volt supply to the drive ICs. Excellent stuff. Let's just confirm class C switching looks okay. Let's turn channel 2 off. So you see now why I want a scope that has the color screen. There we go, class C switching, and we have output as well. So I'm just going to kind of keep that on for a minute. Now the issue actually occurred when we first got this amp on the bench. Everything seemed fine until we went up to 14 volts, and then it wasn't. So I'm just going to power cycle this now with 14 volts worth of input. Now we do get class C switching. So I think that's probably what the issue was all along, but it was kind of intermittent, so it was kind of throwing us off the scent a little bit. But there definitely was an issue with the CSD previously. But yeah, really interesting repair this. Obviously this one's going to need some pretty hefty endurance testing, so we're going to do that, of course. But I would love to get this off the bench and actually just give you a little quick look at what I was intending for this stream to be about. So let's just put the screws back in here. Why is the audio so bad tonight, man? On the stream that I did the other night, it wasn't actually this bad. I don't like, there was an audio delay to start with, but then it kind of went away, didn't it? Yeah, really weird. Like, then it kind of sorted itself out. Maybe it's to do with having filters. Maybe there being filters on the on the mic is a problem. What's up, Joshua? How's it going, buddy? Let's just make sure we didn't knock down to the heatsink. No, it's good. All right, fantastic. So yeah, we're going to endurance test that. But just now, I want to get something a bit more exciting on the bench. I'm quite excited to see whether what I've purchased for these amps gets them fixed, because there's these amps I've been looking at for like 4 or 5 days solid, trying to reverse engineer them. And I think I've figured out how they kind of work. So I want to see whether the fix is solid. Right, let's get my bench tidied up a little bit first. Let's put some of this crap away. Put some stuff there. This is really messy. I've just been so busy lately. This is what happens when I'm really busy. The bench just gets really messy because I've got no time to like just take a break and tidy up. Right, that's for my amp that's coming also. This is for the next amp. Okay, there we go, whatever the fuck that is. In the bin. In the bin! Toothbrushes, loads of toothbrushes. How's the audio? Is it delayed again? Has it delayed itself again? Probably has. Okay, so the amp that I'm going to get on the bench is going to be the one that has clip only different channels, this one right here. Right, gents, PA amp time. Now, a few of you were watching my live stream on Monday where I looked at some of these big as Camco Vortex PA amplifiers. So these are actually really nice amps. These are Class H, so it's essentially like Class AB on the output side. Focus. But the rail voltage is not constantly at its maximum potentials. What it does is it has like a kind of lowish rail voltage to start with, and then only when the sine wave wants to go above that low rail voltage, the rail voltage actually then gets a little bit higher to allow for the higher sine wave, and then if you want to push past that one, it then gets higher again to a maximum potential. So essentially it means that there isn't as much voltage across the output devices for cross conduction, so it's more efficient than Class AB because you haven't got that high rail there sitting away at the crossover point between the transistors. It's much lower, so you can have a much more powerful Class AB amplifier but with a higher efficiency. I think that's kind of how it works anyway, but that's how these work. So these have got all sorts of strange issues. When I first got these on the bench on Monday, I didn't really know what I was looking at, to be honest. I'm not super experienced in Class AB or Class H repair to start with. I'm more of a Class D guy, and these are a bespoke circuit design, and there's no schematics anywhere for these, and I'd never seen these before in my life, so I was trying to work out how they work and try and reverse engineer them a little bit. So over the last few days, I have actually been going through these circuits myself in my spare time, and I think I've got a reasonable understanding of how they work now. So what I'm going to do is just talk you through a little bit about how I've discovered these work, and then we're going to show you what the fault with this one, what it's doing, and how I believe we need to fix it. And it's going to be a really straight, it's not your normal kind of amplifier repair where you've got dead outputs, oh yeah, change the outputs, change the drivers, change the switch mode power supply. It's not that simple. This is a really annoying, strange fault. So let's just get the I'm gonna have to do this at probably a weird angle because of how the camera is. So if I can get something underneath here to lift this up a little bit to show you what we're doing. There we go, that's a bit better. Okay, so actually let's give you this camera. I'm just going to talk you through the board as a whole. So obviously you've got mains coming in over here, okay, in rush suppression over here, a bunch of fuses for different reasons which we haven't really gone into much yet. Then we've got a switch mode power supply. The switch mode power supply is running on a SG3525, nice and simple. The switching frequency I think is like about 120 something kilohertz. It's pretty high. We've got drivers here, IR2110s, that are running some transistors, I suspect IGBTs, on this heatsink, which are switching the transformer here. That then gets rectified. Now the output transistors are all under this big heatsink thing. We don't need to look at that yet because there's nothing wrong with the output transistors. But let's turn our attention to all of the control circuitry over here. Okay, So we've got an auxiliary voltage supply circuit over here with a smaller transformer that has the oscillates as well. This generating plus minus 15 volts. We also have a separate 5 volt supply coming from somewhere that I haven't quite figured out yet, but it's fine, we don't need to know that. These amplifiers are controlled by an MCU. This right here, this chip is programmed. We have a crystal oscillator there to set a clock signal, clock frequency. This runs on, and that's pretty cool. Hopefully that doesn't die, because if it does, you're kind of screwed. So that's what's going on over here. Mostly kind of control stuff, etc. Gain, control circuitry, soft start, everything like that. Now over here, this is where the juicy stuff, this is the preamplifier circuit. So we're going to try and zoom in on this. This is preamplifier, and this is clip detection and class H nonsense over here. So what I have been able to figure out is that we have what appears to be a bias supply over here. So we've got these transistors here, one for left channel, one for right channel, biasing potentiometer, I believe, and we have a 15 volt plus minus supply on there, and then we got a little bit of voltage on the outer pins. No worries, that's fine. We have TL074Cs here and here. These appear to be like audio signal buffers, and they're going to be controlling things like the gain, sensitivity, and just, yeah, buffering preamp signal, that kind of thing. This one in the middle, this one is to do with the clip LED. So the clip LED over here on the side of the amplifier pretty much has continuity, all the red clip light has continuity all the way back to this TL074C. So on a couple of these amplifiers, they have an issue where the clip light is constantly red. Even though the amplifier is functioning perfectly normally and correctly, the clip light is always on. So I'm suspicious of this TL074C. But this amplifier and a couple of the other ones have an issue where the class H rail switching doesn't happen. So it either gets stuck at the minimum rails, or it kind of jumps up by one, but then won't go to the full amount. And what that means is that the sine wave clips off unevenly. And what I noticed is when I was testing the amplifiers, this circuit over here is something to do with the class H rail switching, okay? Because we've got some LEDs here, and these LEDs light up at different points depending on what mode the rails are switched into. So you can see here we've got 8 LEDs, okay? So we've got 4 LEDs for left channel and 4 LEDs for right channel. So let's just take these 4 LEDs here for one of the channels. So when the amplifier is in its minimum rail state, these are all off. When you start to turn up the signal and the sine wave gets bigger and the sine wave wants to go beyond the minimum rail setting, then the rail jumps up to its next preset setting, and these outer 2 LEDs come on. So these outer 2 LEDs are telling you, oh hey, the rails are on mode 2, the next step up. And then when you push the signal further still, even higher voltage, then these middle 2 LEDs also come on, illuminating all 4, telling you that the rails are at their maximum potential. And what was happening was, when I was testing this amplifier and playing a sine wave, some of these LEDs weren't lighting up and the rails weren't switching. So I was looking for problems in this kind of control circuitry. I was looking at issues over here, over here. This is something to do with it as well. Bunch of stuff going on. I was spent like 3 or 4 days trying to reverse engineer the circuit to actually figure all this out to start with, but also to find out what the issue is. And I noticed that the issue actually appears to be the LEDs. Now, I would have thought the LEDs are just signals. They're just like a UI. They're just telling you, oh, hey, this is what the amplifier is doing. But in this case, it appears the circuit is actually using the diode characteristics of these LEDs as a functional part of that circuit. And if the LEDs go bad, then the rails don't switch. You can see I've actually got some solder on this LED here. I removed it to try and get some readings from it so I could order some replacements. So let me firstly show you this problem in effect. So I'm going to zoom out a bit here. I'm going to plug this amplifier into the mains. Actually, let's keep that zoomed in so we can show you the LEDs in a minute. Let's get this all plugged in and I can show you what this amplifier does. And hopefully, with some of the parts that I've ordered, it's not going to do it anymore. What's up, Jerry? How's it going, my bro? Okay, so yeah, this has power con by the looks of it. So let's plug that in there. Plug that in here. Plug that into the mains up here, which is currently off. Now what I need to do is I need to plug in some speak-on connections as well to the amplifier, so we can actually measure the output sine wave on the scope. And we're also going to need some input signal as well, so we're going to need a preamp card as well. Shove that in there. And we're going to need an XLR. And I'm just going to take the ends of these speak-on wires and hook them up to my scope so we can have a look at the sine wave together. Let's just fix the audio delay again. There we go, it should be fixed now. The click of the speak-on tripped the mic. What? Eh? I'm just capping off the negatives of these speaker terminals because obviously I don't want them to accidentally touch something. Seems like it happens when there's a sudden loud sound. If I clap, so is the audio now delayed? Because that'd be weird. Maybe it's when it clips. Let me know if it's delayed or not now. Didn't do it. What the heck? Maybe it's electrical. Maybe it's something on the ground. Maybe it's like a ground. As I plug the wires in, these are some quite long wires. They're going to have a bit of capacitance. Maybe there was like a little bump on the ground, which is all connected all through my PC. So maybe it was that. Right, so let's get this oscilloscope probe over here. I do need to be kind of careful with this because this is going to have a high voltage, very, very high voltage sine wave on it, and I don't want it to touch anything and short out the outputs of this amplifier. So let's get that one up there, and then this one as well onto channel 2. Well, I'm going to unplug the speak-on and plug it back in. Let me know if the audio goes out of whack again. So I'm going to unplug the speak-on, plug it back in. There we go. Let me know if the audio went out of whack just then. No, it's fine. I think it might just be coincidence, to be honest, guys. You know. Right, so that's one scope channel hooked up, and let's go for the other one. Okay, so the scope should now be connected to both of those outputs. I'm going to go for a low frequency sine wave here, about 50 hertz or something like that. So let's zoom out on the scope a little bit on the time divide, and let's reject my frequency, which we're on at the moment. Okay, let's connect up my XLR. Into the amplifier here. Make sure we're on mono mode. Okay, cool. So I think we're ready to go. To power up. Let's just get this camera onto the LEDs here so you can see what they're doing. So we've got power connected there. Speak on is in. XLR is in. Nothing on the board that looks funky. We've got our scope probes hooked up there with each channel. It's connected. Yeah, okay. I think everything's safe and ready to go. So safety glass is on. And let's turn on the mains, shall we? So that one on first, and then this one. Let's get that turned down. Okay, and then I'm going to power the amplifier up just now. Why am I so scared? I've done this a million times. I'm just worried in case I've like missed anything. Okay, amplifier's coming alive. All the green LEDs have come on and they've just gone off. Okay, cool. So all the LEDs are off, amplifier's powered up. We currently have one red clip LED on there, as you can see, even though there's no signal playing or anything like that. So that's one of the problems. But the other problem is that as we turn the signal up, which I'm going to do now, hopefully this is okay. Yep, we get a signal there. As I turn the signal up, we should start to see some LEDs come on here when the rails switch. There we go. So we've got some couple of LEDs coming on there as the rail switch. Now that LED that I removed there, that is actually coming on, and because it's quite bright in here, it's kind of hard to see. But can you guys see that? Can you see that LED coming on there? Two LEDs coming on. So they come on as the sine wave increases in amplitude. Then when we go all the way up to the top, all four LEDs come on like so. But give this amplifier a few minutes of operation and I don't think those LEDs are going to still be on. Because when they get warm, they start not actually coming on. And it happens when I blow a little bit of hot air over them. So let's turn the hot air gun on. Let's just power this off. So I'm going to turn the hot air gun on. I'm going to turn the temperature down kind of low. Okay. Someone said the sound cutted from the top cam hat. Mic check, mic check. Is it working? Mic check. Mic check. Yeah, I think it's working okay. It seems very bright actually though. Do you know what I mean? Do I have any filters on here? Turn the gamma down a little bit. It seems really bright. That's a bit better. So I'm going to power the amplifier up again. Okay, and I'm just going to blow a little bit of hot air over these LEDs and watch what happens. And this shouldn't happen, by the way. And this is what happens when the amplifier is warmed up with a bit of operation. So if I just turn this one up, you see the LEDs come alive just there. Now if I just blow a little bit of hot air, go on please. Yeah, there we go. That one there just cut out for a second and the sine wave dropped out a little bit. Go on, stop behaving for the YouTube. 3 days ago you were cutting in and out all over the place. Maybe it just needs to warm up a little bit. Especially this LED that I'd removed was mega screwed. There we go, there we go. So as you can see, this LED is not on anymore. Now it is, but if I make it just a tiny bit warm, I've got this on a really low setting. Now the LED turns off and we're missing half the sine wave. Now it goes into protect. So that shouldn't happen, okay? And that was happening by itself without me blowing hot air. Look, I'm not blowing hot air over it at all now. So no hot air and no LED, and we're missing half the sine wave. So weirdly, the issue does actually seem to be that the LED needs to work in order for the Class H rail switching to actually operate, which is wild, hey? There we go, look, it's doing on the other channel as well. I haven't even touched, like, yeah, the other channel now isn't working either. So that has been my issue. That alongside constantly on clip LED. So I think my guess is that in order to fix this, we just need to fit some new LEDs, and also I think I need to fit a new 074C op amp that forms part of the clip detection circuit. So we've got some new LEDs here, and these, unfortunately, because this amplifier was made quite a long time ago, the green LEDs that it uses here have a forward voltage of 1.9 volts. Now, trying to find modern LEDs that are green that have a forward voltage of 1.9 volts in this package size, in this size, is actually very hard. So I've actually had to go with red LEDs instead, which is whatever in it, as long as it works the same. I tried to match the characteristics as close as possible. Obviously I don't have a schematic or a data sheet or anything for this, so I had to remove the LED. I had to wire up a current limiting resistor in series and see what the forward voltage was. I also had a look and saw what the forward current was and all that sort of thing. And then I tried to buy some LEDs that were as close of a match as possible. And I hope I have hit some good ones. So let's take the hot air gun. Everything's off, the mains is disconnected. So let's turn the hot air gun up and let's remove these LEDs, remove all of them, and let's replace them with the red ones and see if that makes it work. I'm also going to replace the 074C while we're there. Which way do you... Okay, so you want the positive red side up the top on all of these. Now, heating LEDs like this actually damages them a bit. So obviously when we solder in the new ones, I'm going to do it with the actual iron itself rather than with the hot air gun. Okay, let's tin those traces a bit. Oh, that's a point. So someone says the LEDs were much brighter on. The LEDs were much brighter when you powered the amp on than they were in operation, said 13 BTR. When I yeah, they definitely were, but I think that's just kind of how it works, because what I used in order to get the forward voltage is I actually removed one of the LEDs and I used an external circuit to get the forward voltage. So I had to kind of match that up. But yeah, I agree, the LEDs were dimmer when it was in operation compared to when it was powered up. But fortunately, I do actually have a fully functional working example of these amplifiers. I got sent 7 of these amps. I've got 7 of these Camco Vortex amps here. And one of them that was presumed faulty was actually fine. Just the plug socket had a loose fuse in it, so it was making an intermittent mains connection, and the amplifier wasn't happy about that. So I do have a working example of this amp, and the same behavior occurs there as well. Actually, when you power the amps up, initially they're bright, the LEDs are pretty bright, but then when they're actually coming on and going off with the rail switching, they are a little bit dimmer. So I think that's just kind of, you know, how the circuit works, a byproduct of what it is. So let's just work out which way up these. Oh, that's nice and bright, isn't it? Bloody hell. Okay. There we go. So we are, yes, okay, fantastic. That way up. You know what? I actually made a small mistake there. I shouldn't have tinned these pads, because I'm going to be soldering the LEDs. So I want those to be flat pads, not like bulged tinned pads that I'm going to use hot air with. But I think it's a bit late to go back now to try and make them as flat as possible. But guys, this is ridiculous. No schematic, no service manual, no data sheet. How the heck would you figure something like this out? This was like, okay, I say it was like 3 or 4 days. It wasn't 3 or 4 days of full work, but like this was like a good few hours, like many hours of me staring at these circuits, probing everything, like just probing stuff between the good amp and the bad amp, like reflowing parts, removing bits, testing bits, and trying to figure out until, you know, what, that's the last thing you'd think. That is the last thing that you'd think is, oh, the LEDs themselves are bad. You'd never think that, would you? But here we are with what seems to be failed LEDs causing this amplifier to not function correctly. Wild. Bit of flux and some tweezers, and we're going to use the iron. I'm going to turn the iron temperature down as well, actually, to about 350, which is really low for how I usually use it, but I just don't want to risk damaging these LEDs with over temperature. There we go, there's one. Now the green little spots need to be at the top by the looks of it. I know from looking at like videos and stuff on YouTube of these amplifiers, most technicians will actually turn these away because they can't get a schematic or a service manual. And I was tempted, you know, when I sort of got these in and I looked for a schematic and I looked at the kind of faults they had, I was like, you know what, man, I don't know if I can do this. I don't know if I can devote the time to this. But I thought, you know what, no one really is going to work on these. So if I can familiarize myself with these amps, if I can learn them and learn their common faults and get good at them, then that might be a real strong point for me. That might be a real good thing to have under my belt, because then I'll be one of the only people that really gets these amps and can service them, and I can charge, you know, decently for that. The only other places that will service this really is Camco in Germany, because they have all of obviously the service manuals and schematics. I'm sure there's plenty of technicians that are just like me that, you know, would happily take this on as a learning curve and as an experiment, but so many won't. So many techs will just be like, nope, that's a waste of time. That's gonna take absolutely hours to figure out. So these devices, these ICs, these are LM211s. So yes, they are comparators. Comparatores. Okay, last one. I really hope this works, you know, man. Like, I'm not super confident in my like LED parts choice selection skills, because, you know, I'm not super knowledgeable about, you know, LEDs as a thing. But I do hope that I was able to understand their readings, characteristics, datasheet, etc. enough to pick some that are going to work here. Okay. Now, while I'm at it, I am going to go ahead and change the 074Cs. I think these things, these 074s, do have the potential to fail because they are kind of in line with the signal path and, you know, external stuff. So plugging things in, different ground potentials, etc., can stress them. So I think it might not be a bad idea just to batch replace all these 074Cs while we're here, because I think this one has an issue, this clip detection one anyway, so they're all a bit old now. So I'm going to batch replace these 074Cs, and hopefully that gets rid of the clip light being on at all times problem that this amp's got. Are the LEDs basically what you narrow the faults down to so far? Yeah, pretty much. That and this 074 possibly, I hope. So not this one, that one's probably fine, but I'm going to replace them all anyway. This middle one here seems to be to do with the clip detection circuit and running the clip LED, so... I guess what I mean is I just don't want to fit any LEDs that are either going to get overdriven by this circuit and like short and then cause damage, or put too much stress current-wise on the circuit that's running them. because these LEDs are functional, not just signatory. Is that even a word? No, that's not a word. You know what I mean? They're not just providing a feedback to the user. They're actually forming a functional part of the circuit here as a diode. So I need the characteristics to be the same. What's up, badass? How's it going, my man? Now, I am actually going to use the iron again for these because op amps similarly don't like being heated. So, yeah, I'm going to use the iron to solder these in place. That one's on a tiny bit of an angle, but it's fine. I don't really like doing these with the iron, but I'm not happy with that angle. I'm just gonna quickly blow a little bit of hot air over the pins. Stay away from the actual chip itself. I'm just gonna straighten that up. There we go. Ah, no! At this point I might as well just hot air it. Hope for the best. Oh, H1 Nicholas, good to see you there, bud. Didn't catch you joining the stream there. Hope you're doing well, my man. Nicholas, what do you think of the fault with this? Nicholas, did you scroll back in the stream and see what the issue was with this? It's crazy. I'd love to get your thoughts on it. I envy your eyesight. It won't last forever, buddy. I'm gonna need them glads sooner or later, probably. My hands are actually a little bit shaky tonight. I usually have super steady hands. I just need to take some deep breaths. Okay. Okay, we are all soldered in, so now it's time for a test, and I hope that everything goes well. We have 3 new op amps, and we have all new red LEDs. Nicholas says, I do not think it's the LEDs. Placing LEDs in series to drive a stage even when with a buffer is not a good idea. Everything was pointing to it being the LEDs though, man. Unless it's the unless it's the... No, actually, you know what, Nicholas? I actually proved it was the LED to myself, because what I did is, with these green LEDs, I was thinking the same thing. I was like, it can't be the LEDs. That would make no sense. I turned the hot air gun on super low, super low pressure, super low temperature, just so that the hot air was only going over the LED. And the second it went on the LED, it turned off instantly. On a super low temperature. I'm talking like 60 degrees Celsius, right? Then I was like, right, okay, let's just double check, confirm this with myself. So I removed the LED very carefully using the soldering iron, not the gun. Just very carefully desoldered it, placed it, let it cool down on the top here. Then I took my multimeter, put my multimeter across the LED so that it lit up green. And when I did that, it lit up green, but then the values on the multimeter, the diode readings, were like fluctuating all over the place, up, down, higher than they should have been. And the LED was like turning off a little bit, while my multimeter was like very solidly planted on its contacts. So then I held the multimeter probes on the LED and just blew my hot air a little bit nearby, and then it just went off and didn't come back on for ages. So the LEDs, maybe they're not the root cause, but they were definitely bad. 100%. I proved that. So I mean, for my own like ease of life, I hope that there's nothing else wrong, but I would be very surprised if it was just LEDs causing that issue. But I have seen a couple of times before LEDs be used for that kind of function before, and so yeah, I don't know. Okay, op amps all good. Sanity check all the correct way around. No solder bridges between pads. LEDs, let's just check that they're all in the correct way around with my multimeter here turned on. Wait, did I just put these in backwards? All of them upside down. I did, didn't I? Oh my life. How did I manage that? I tested it out of the board and I was like, yep, that's the correct way around. How did I manage that? It was definitely the red probe on top, wasn't it, for illumination? Connie said, I told you, I wasn't looking at live chat too much. How did I manage that? Fuck. Let me just grab one of these other boards, just to confirm that I definitely have done that. For fuck's sake. This is the one that I got the electric shock off before. Yep, I put them in backwards. Oh my life. Alright, well I think we're going to have to hot air it, but I'm going to turn the hot air gun down to a nice low temperature. And just flip these round, annoyingly. Yeah, Connie, I'm sorry, buddy. I wasn't really checking live chat too much, but I appreciate that you were trying to warn me there. Yeah. Fortunately, these boards don't seem to have that high of a thermal mass. Like when I was desoldering stuff earlier on, you know, like a few days ago in the other areas of the board, the solder was melting really quick. I think that they're using leaded solder as well, rather than lead-free. So I was quite pleasantly surprised by just how easily stuff was desoldering and everything. So at least we haven't got crazy thermal mass and stupid lead-free solder to deal with. Okay, well, I hope that that little hot air gun session hasn't been too detrimental. I did turn the temperature down quite a lot, and I tried to avoid blasting over the actual LED themselves. So I guess we'll just have to see. I'm going to obviously test it with my multimeter on diode mode just now, just to make sure they all still light up, etc. I'm married, not yet. No. 1, 2, 3, 4. It's got to check brightness as well, make sure they're all about the same brightness. This one seems a bit dimmer than the rest of them, but maybe it's just my eyes. Yeah, maybe Yashwan, maybe. Okay, cool. So I guess we give it a test now then, don't we? Guess we give it a cheeky little test. So let's put the preamp board back in. Like that. Here we go. And we want our safety glasses probably on. Okay. So, yep, we have signal going in, everything's good there. Can go in the bin. Go there. That can go up the top. That's connected to that, that's connected to that. Okay, yeah, tweezers. Alright, so I think we are ready. What are we repairing right now? Camco Vortex 6. With some ridiculous problems that we don't have a schematic or a service manual for. You're going to focus on my hands, focus on the amp. There we go. Okay. So mains plug down here. Signal, that's all nice and low. Let's power that on. Okay, amplifier coming on. Okay, nice bright red LEDs and off. Okay, now let's try some signal then, shall we? So we have signal. Oh, by the way, let's... Oh, guys! Yo! That clip LED that was on the side. It's gone. That was my guess. That was my guess. I was like, it's probably not going to be this, but let me just try anyway. Fuck. No more constant clip LED. Right, that has made my day. Now let's see whether we can get all the way up to the top of the sine wave. That's promising. Yeah, boy. That is working a treat. Now let's check the other channel. Uh-oh, okay. That was the LED that I thought was dim, wasn't it? That was the LED that I said looked a bit dim. So I think that one I probably cooked with the... that's why I didn't want to use the freaking hot air gun on the LEDs. Okay, so let's remove that one and bang in another one. Did I buy... I hope I bought extras. I might have only just bought enough LEDs because I was going to redo the LEDs in all of these amps, even the one that's currently working, just as a service. But I might have only just bought enough LEDs to do that with. Hopefully I bought a few spares. Check the resistors in series with that. Yeah, okay, so the amplifier's off, mains is off, okay, everything's fine. So that LED does come on with the meter. So in terms of what's in series, the resistors that are in series, I don't think there are any resistors in series. Are there? Hang on a minute. Right, hang on a minute, what's that? Got that one. Okay, that one there. Okay, that's in series. Yeah, the resistor there is in series. So we've got that one there, that one there. Right. Okay, let's put it onto resistance setting then. Let's just check these resistors. So we've got 3.3, 3.3, 3.3. This was the bad one. 3.3, 2, 3, yeah. 3.2, 2. Seems okay. I'm going to swap that LED out. Yeah, LEDs really don't like being hot, and I'm really pissed off with myself for putting them all in backwards on this one initially, and then I had to hot air them. AMO, man, thank you very much for the kind words. I'm trying my best. I'm trying my best. We've had one success. I'm super happy that I managed to get the clip LED constantly being on issue resolved with the 074. That was just a total guess. I just traced back where the LED was originating from, and yeah. I'm happy with that. No, that was a train in the background. I got a railway line fairly close by. No, the LED wasn't put in reverse. No, that's fine. Okay, let's wait for that all to cool down a little bit. That feels pretty hot. Bit of isopropyl. Okay. Right, let's give this a crack now then. Oh man, that LED went out early, didn't it? Maybe I haven't found the problem. Maybe, just maybe, I haven't found the problem. Maybe it's not the LED. Maybe it's the LM211s. Right, well the ones on this side were going bad before. They were like kind of turning off. So let's just leave the amplifier powered up for a minute. And let's just see whether the LEDs on this side turn off at all after like some operation. Maybe if I blow a little bit of hot air. Yeah, I could swap over some of the 211s. That's another thing I could do. Yeah, I could swap over the 211 from the good side to the bad side. That would kind of probably tell me a little something, wouldn't it? Okay, so this is quite hot. This hot air gun is at 200 degrees. Previously, the LED was turning off at only like 60 degrees. So, if the issue was on the main board, I think those would have turned off by now. I don't think that LED's particularly straight though. I wonder whether I've just overcooked this one as well. I'm going to replace it one more time, guys. Oh yes, I've also done that, Connie. I've also done the infrared meter across these boards to see if anything was overheating or getting hotter, like if any of the ICs were getting hotter than the others. Nah, everything was running well within sensible temperatures, 30-40 degrees Celsius at max. None of them were getting any hotter than any of the others, so... No, it's not in reverse, guys. Not in reverse. You can see the little green marks on there. Just get this back onto diode mode. It is A-OK. So I don't want to switch the LEDs around too much because they don't like the hot air. So I want to try and avoid switching them around if I can. Like, obviously it would be like an interesting test, but yeah, I don't want to keep switching them around unnecessarily if I can avoid it. Right, let's just try. I've just shifted it over slightly. Let's just try that and see what happens. It goes out really early again, doesn't it? Okay. Okay, I'm going to swap it one more time. Actually, yeah, maybe that's a good idea. Maybe what I'll do is I will risk it a little bit, and I'll swap that LED for one of the others, just out of interest to see. So I'll swap it with this one on the end here, okay? The LM211 has output transistors. This output transistor may be bad. Yeah, for sure. So if this doesn't change, so basically if I swap these over and the LED that doesn't light up is still on this one, then what I'll do is I'll swap this LM211 here for this one here. Right, let's let that cool down. Let's let that cool down and read some live chat while that cools down, shall we? I want to see you and Sam do a demo car, man, that'd be freaking cool. I do kind of wish Sinewave 02 lived quite close to me. Is the negative rail not getting the signal to boost it up to the next level, the Class H stuff? That would possibly be the case if the 211 was bad, so that's what we're going to try next if this doesn't do anything. My girlfriend who lived in America used to have one of these cargo trains come through past her house, and it shook every 15 minutes. That's crazy. Yeah, fortunately, there's not really any physical vibrations, very minor. Sometimes the cargo trains go by at night and it's like, if we've got a little glass on the side that's just touching something else and then get a little bit of vibration, but barely. I used one at my daughter's 18th a few days ago and blew up a Jammo. Oh crap. Jokes. You could also build in LF audio products. I'd love to do that. I've actually got the LF audio voltmeter sitting here. I just haven't wired it up yet. Let's check the, yeah, that's not bad idea. Let's just check the diode mode reading on these LEDs as they illuminate. So this one we're reading 1540 there, and the other way round, open. 1540 again, the same. 1540 the same. Again, yeah, these are all the same. Alright, so if this LED is still the one that doesn't come on, then we're going to swap the 211. Okay, let's power up and have a look. Ah, well there you go, still the same one. So I guess we're swapping the 211s around. Alright. Interesting. I think that LED that you scrapped is good. Yeah, I agree. The LED that I scrapped is probably still good. So I'll put it to one side and I'll use it in these other amps. So now let's wait for the amplifier's rail voltage to dissipate, and let's just quickly swap the 211. I'm not going to keep this stream going for too much longer, guys, because it's pretty late now here in the UK. It's like 11:15 at night. So I'm just going to swap the 211s and see what that does. And then depending on the outcome of that will be my next move for a future stream. So we're going to swap this 211. I'm going to swap two next to too next to each other, just because that keeps all the heat in the same kind of area, doesn't it? Let's turn the hot air gun back up to my normal operating temperature of about 400. Connie, yeah, good job that you did tell me to switch the LEDs. I probably would have got there eventually, like after replacing the LED for the 3rd time and still seeing that it was bad, then obviously we would know that the LED there wasn't the thing that was the problem. It's not going to be these capacitors. These capacitors are just in line with the supply voltage, the plus minus 15 volts. So it's not going to be those. So yeah, the issue is got to be, it's got to be either the 211 or one of the resistors maybe here, or maybe something somewhere completely elsewhere in the circuit that's the problem, that's just influencing this circuit here, which would be a real pain in the butt because then I'd have to go searching again. Right. You see what I mean by how easy this board is to solder to? Oh, like the solder stays melted for ages after. I keep accidentally knocking it off. Right, there we go. Okay, so we're going to have to wait for that to cool down. I've got a brand new Sundown Salt 4, hooked up the power to it and it immediately started smoking. So did it start smoking the second that your power wires touched the terminals, or did it start smoking the second that the remote went to turn the amplifier on? Yeah, I just didn't want to. Oh, remote turn on. Okay, yeah, that's not your fault. Sundown needs to warranty that. Absolutely. There's no reason. There's nothing that you can do as an end user. There's nothing that you can do wrong that would cause the amplifier to smoke up instantly upon applying the remote. There's nothing that you could have done wrong. Even if you'd wired the output terminals to 0 ohms, that wouldn't cause that. Even if you'd connected 12 volts to the output speaker terminals, that wouldn't have caused it. If you'd reverse polarity, again, that would be a different issue. It would have smoked up when you touched the power wires, not when you touched the remote. There's nothing that you could have done to cause that. That is a component failure. That is not your fault, and you need to push for that warranty. Hell, I'll even say go to small claims court if they won't warranty it. So what saved? Yeah, that's all the saved glasses. I'll tell you who is good with warranty. My main guys, Taramps. Fucking great at warranty. They just send you out a new amp. Right. Gary says, I bet it'll be worse with the IC switch. Don't say that. Right, so we swapped those two around. So if that was the issue, the problem should have probably moved to this LED. So let's see what happens, I guess. What the fuck? They all came on, okay. 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 Nani? So I guess that must mean that the issue is the 211 because we superheated the 211s. Yeah? Do you get what I'm saying? We heated the 211s to the point of desoldering, which can, in the same way as putting your graphics card in the freaking oven, can bring it back to life temporarily. So I suspect that's a similar thing to what's happened here, is that we've brought back to life the 211 that was bad by superheating it. So my next move then with these amplifiers is going to be to replace all of the freaking 211s on all of these, because that seems to be maybe where the issue lies. It won't have been a bad solder joint, they were soldered in real nice. So there we go. I'm super freaking gassed that I fixed the issue with the clip LED with the 074C. We have honed in more so on the issue with the class H switching. I'm still going by the green LEDs being temperamental, because like I say, I removed one of them and it was playing up out of circuit on the multimeter. So what I'm going to do in all these amps is replace all the LEDs for the red ones, replace all the 211s, and also replace all the 074Cs along this side of the board where the preamp circuit is. And I'm hoping that that's going to clear up most of these issues with these amps. One of these amps I've got in does have a switch mode power supply fault, however, which is going to be a bit more complicated, probably. But that's a story for another day. Gents, it has been an absolute freaking pleasure. I've massively enjoyed this live stream. I hope you have too. I hope it's been educational and interesting. Interesting stuff to keep us occupied. So, thank you very much for thank you very much for joining me. Yeah, any last questions or anything? Can I take a ground from the amp and hook it up to the ground of the speaker wire? Only if you confirm that the ground on the speaker wire is actually a true ground and not an inverted negative, sorry, not an inverted positive that is bridge. So you can do that provided the amp is a half bridge, firstly. Secondly, that it's a multi-channel, ideally. Thirdly, that the speaker negative that you're connecting to, you've checked is a true negative and not an inverted positive that you use for bridge mode. Usually you can use left channel negative, which is a true negative, and you can check which one's a true negative because you'll have four, if it's a 4-channel amplifier, you'll have 4 speaker terminals that are all connected to each other, that all have continuity to each other, and those are all the true negatives, the true grounds. So yes, you can do that and give that a go, see if that helps. Thanks for the stream. Clocked an hour and a half of ads. Clocked an hour and a half of ads? What does that mean? You had an hour and a half worth of ads? No, surely not. Yeah, it's time for sleep. Yes, it's late here as well. But yeah, I appreciate you guys sticking with me, and just yeah, let's run an ad. Thanks for sticking with me, and yeah, I'll see you later on in the week. Have a great evening, and see you next time. Let's hit the ad button. Tee hee hee.